Hello friends, welcome to the video lecture series of Engineering Mathematics 2. In previous video, we discussed reduction formulae. In reduction formulae, we expressed integral of higher index parameter term to low index parameter term. The parameter doesn't occur at an index place. Then how to solve those integrals? So those integrals solved by the Leibniz rule. That Leibniz rule is also called the differentiation under integral sign rule. Some problems on differentiation under integral sign rule. What is the first Leibniz rule? Differentiation under integral sign rule or Leibniz rule, first Leibniz rule. If I alpha equals integral a to b f of x alpha dx, then derivative of I with respect to alpha can be written as integral a to b del del alpha f of x alpha, and integration is being carried out with respect to x. Means this ordinary derivative, it comes inside of integral and it becomes the partial derivative then. Here the alpha is the parameter, a and b are constants. When a and b are constants, the first Leibniz rule will be using, and if the limits of integration are given in terms of parameter, either lower limit or upper limit or both the limits are given in terms of parameter, the second Leibniz rule will be discussing. Now the problems on first Leibniz rule show that this integral is equal to right hand side. Here the limits of integrations are 0 and 1, and these are the constant terms, limits are constants. The first Leibniz rule I am going to apply. So let us denote it by I or I alpha. This integral I have denoted by I alpha, or you may call it as phi alpha also. This is the given integral. Now, this integral is our equation 1. Now, differentiate with respect to parameter. I am differentiating with respect to parameter alpha. The di by d alpha is derivative of right hand side with respect to alpha, and by Leibniz rule now, or by differentiation and under integral sign rule, in short I am writing in this way, DUIS, differentiation under integral sign rule. This derivative, ordinary derivative, is going to become the partial derivative now, del alpha x power alpha minus 1 pi log x. This is partial derivative, this is ordinary derivative. You may call it as a del or dabble. Now this equals the partial derivative with respect to alpha, keeping x constant, integral 0 to 1 as it is. Then x is constant, means log of x in the denominator is a constant term for derivative. Or in short you can say the alpha is variable for derivative in this term, and derivative of x to the power alpha is x to the power alpha into log of x, and derivative of minus 1 is a free constant term, derivative of minus 1 is 0. Now this log x gets cancelled. Here I use this formula, is derivative of a to the power x, constant power variable, is a power x log a. Okay, this formula you use many times in 12th standard. The derivative of x to the power variable or derivative alpha means the derivative of x to the power alpha is x power alpha log of x. Here log of x cancels. Then now it is a term of integration. Integration of x power alpha with respect to x. Now for integration x is variable, alpha is constant. You may treat this as a constant. Now integration of x power alpha is x power alpha plus 1 by alpha plus 1. Means integration of x to the power n is x to the power n plus 1 by n plus 1, like that. Then put x equal to upper limit and lower limit. If you put x equal to 1, then 1 raised to power this thing will be 1. And if you put x equal to 0, the 0 by this will be 0. Means di by d alpha is equal to 1 by alpha plus 1. Okay, this is the differential equation in terms of alpha we have found. Now, initially we deal with x, that due to definite integral, we solve definite integral up to this step, and the x has been removed. Now we have the equation in terms of I and alpha. Okay, this may be asked as an MCQ. The question may be asked like this: if if I equal to this thing or phi equal to this integral function, then following differential equation satisfies, and this will be the correct answer in the option. Now, after this, to separate variables, I am going to separate the variables. This differential equation I am going to solve, separating variables. This d alpha I am taking in the numerator. Now, when you separate variable, this is d, Now, take integration of both the sides. Integral of 1 with respect to I is I or I alpha, log of alpha plus 1. And this is indefinite integral, therefore I am putting integration constant as c. This is our equation 2. Now it remains to find out value of c. This is indefinite integral. We have to find out value of c. In order to find out value of c, I will make use of this I alpha or I. I will use equation 1. Now, the boundary conditions we can find out. The boundary conditions are not given. Now, for which value of alpha I is 0? That you try to find out first. It is not necessary that for value of parameter alpha equals 0, this will be 0. But you, first of all, you try to get the value of I for alpha equal to 0. If I put alpha equal to 0 here, this is value of I. If I put alpha equals 0, so what will happen? 0 to 1, x to the power 0 minus 1 by log x, and x to the power 0 is 1, 1 minus 1 is 0, and integral of 0 is 0. Means value of I is 0 for alpha equal to 0. I is 0 for alpha equal to 0, and this boundary condition I will be using here in order to find out value of c. Now put alpha equal to 0 and I equal to 0, because for alpha equal to 0, value of I is 0 in this way. The I is 0 for alpha equal to 0, and log of 1 is 0, therefore log of 1 is 0, therefore c is equal to 0. So in this way we found value of c. And putting value of c here in equation 2, this equation 2 implies I is equal to log of alpha plus 1, and value of c is 0 plus 0, no need to write. So in this way, I is equal to log of alpha plus 1 we have proved. The value of integral we have proved log of alpha plus 1. Here I is this integral. Now the second problem. In this case, again, let us denote it by I alpha or phi alpha, you can say. Integral 0 to infinity, e to the power minus x by x as it is 1 minus e to the power minus alpha x. This is our equation 1, and this is our phi. Now differentiate with respect to alpha. Here alpha is the parameter. In the examination, you will be given a as the parameter also. 0 to infinity, e to the power minus x by x, 1 minus e to the power minus alpha x. Then by differentiation under integral sign rule, take derivative. This ordinary derivative will be a partial derivative when it comes inside of integral e power minus x by x. This is as it is. Now take derivative with respect to alpha. This partial derivative, keeping x constant, because for partial derivative alpha is variable and x is constant now. Now 0 to infinity, the derivative I am taking, e power minus x is constant for derivative because alpha is variable for derivative, multiplied by derivative of free constant 1 is 0, derivative of e to the power minus alpha x with respect to alpha is same, e to the power minus alpha x, and this multiplied by minus of x, because alpha is the parameter. Alpha is variable of derivative, you can say. Now here x gets cancelled, then this minus minus will be plus 0 to infinity, e to the power minus of x multiplied by e to the power minus of alpha x is remaining. Now 0 to infinity, by law of indices I am adding the powers of e. Minus x minus alpha x, take minus x common, then this will remain. Now take integration of this one with respect to x. After simplification of the derivative, now you take integration with respect to x. Integration of e to the power minus of x is the same thing, divided by coefficient of x. You can write minus of 1 plus alpha. This is integration, and limits are 0 to infinity. Now this is equals e to the power put x equal to infinity, e to the power minus infinity is 0 and e to the power 0 is 1. Now if you put x equal to infinity, e to the power minus infinity will be 0. 1 by minus alpha plus 1 is common, because here we have integrated with respect to x. X is variable, alpha is constant. If you put x equal to infinity, e to the power minus infinity is 0 minus. If you put x equal to 0 now, then e to the power 0 is 1. Now this is equal to minus minus becomes 1 by alpha plus 1. Now therefore di by d alpha or d phi by d alpha is 1 by alpha plus 1. So this differential equation and this differential equations are same. So this much part already we have solved. So this is our equation 2. Now separate variables, alpha and phi I am separating. Take integration in the same step. Integral of 1 with respect to phi is phi. Integral of this is log of alpha plus 1. And integration constant is c, because this is indefinite integral. This is our equation 3. Now we have to find out value of c. But in order to get value of c, make use of the given definition of the function. How the function is defined? Phi equals 0 to infinity e power minus x by x 1 minus e power minus alpha x. Now for which value of alpha phi becomes 0? So if you put alpha equal to 0, e power 0 will be 1, 1 minus 1 will be 0. Means for alpha equal to 0, what will I get? 0 to infinity e power minus x by x 1 minus, and if you put alpha equal to 0, e raised to power 0 is 1 again, and 1 minus 1 is 0, 0 multiplied by this will be 0, and integration of 0 will be 0, means phi is 0 for alpha equal to 0. The value of phi is 0 for alpha equal to 0. So this boundary condition I am going to use here. Put alpha equal to 0 and phi is equal to 0. So phi equals 0, log of alpha plus 1. The same thing we have done here. Log of 1 is 0. Here I am writing log of 1 is 0. Base of the log is e, because it is a natural log. But if we don't write the base, that is assumed that the base is e. The c equal to 0. The putting value of c in equation 3 now. Equation 3 employs phi equals log of alpha plus 1 plus 0 plus c, means plus 0. No need to write. In this way, value of phi we have found. The phi is what? Phi is this integral. This integral value, log of alpha plus 1 we have proved. Value of this integration is log of alpha plus 1. Once again I repeat, in examination, this may be asked as an MCQ, differential equation, or in examination, if phi is given and the differential equation is given, so you will be asked to find out value of phi again. You have to find out the value of integral. Phi is nothing but the integral. So this may be asked as an MCQ. In that case, this differential equation will be given to you. Now, next problem. Using differentiation under integral sign rule, find d phi by dA, where phi is this. Hence, evaluate the given integral. Okay, this is the question. Now, We are going to solve this one. The phi is given to you. Differentiate 1 with respect to a. Here a is the parameter now. A is parameter that will be given in the examination. We are differentiating with respect to a. In place of a, you may be given alpha also. The d phi by dA. Directly I am writing del a of e power minus x e power minus ax by x sec x. Then take derivative of this function with respect to a is parameter. Keeping x constant means here x sec x is constant because we are taking x constant now. We have to have the partial derivative with respect to a. Derivative of e to the power minus x minus e to the power minus x is constant for a is 0 minus derivative of e to the power a is same thing, and this multiplied by derivative of minus ax with respect to a is minus x. Take derivative very carefully. Now this x gets cancelled. 0 to infinity. This minus minus will be plus e to the power minus ax multiplied by 1 by sec x is cos x. Now this integral you can evaluate using by parts, but in short I tell you how to evaluate this integral, or you can directly use the formula also. Integral 0 to infinity e power minus ax into cos bx for the limit 0 to infinity equals a by a square plus b square. And if sign is there, in that case b by a square plus b square for cos a by a square plus b square. Now if I use this formula of integration directly, in examination you can directly use the formula. The a divided by is this integral we have solved completely. This is 1. 1 is b, no? 1 square. 1 square is 1. The d phi by dA value we have found. The first part we have done, and this may be asked as an MCQ. Using DUIS rule, find d phi by dA, that we have done. And hence evaluate integral. We have to evaluate this integral also. We have got this differential equation, separate variables, separate a and d phi, take integration. In that step, integral of 1 with respect to phi is phi, integral of a by a square plus 1 with respect to a is 1 by 2 log of a square plus 1. This is indefinite integral, integration constant c I am putting. The value of phi we found. This is our equation 1. Now, how do you find out value of c? As I told you, we have to find out the value of c using given definition of the function. Function is given in this way: e power minus x minus e power minus ax by x x. This is given to you. Now, for which value of parameter a, phi becomes 0. If I put alpha equal to or a equal to 1, the e to the power minus x, e to the power minus x will be 0. If I put a equal to 0, then in that case phi will not be 0. E to the power minus x by this will remain. But if I put a equal to 1, just for a equal to 1, what will happen? The phi is equal to, or you can write a phi of 1 also here. 0 to infinity, e power minus x, put a equal to 1 by x sec x, and e power minus x minus e power minus x is 0. 0 by this will be 0, and integral of 0 is 0. Means phi of 1 is 0, or value of phi is 0 for alpha a equal to 1. I repeat, value of phi is 0 for a equal to 1. So this condition I am going to use. A equals 1 and phi is equal to 0. This condition I am going to use. So put phi is equal to 0 and a equal to 1. If you put here, then 0 equals 1 by 2 log of a square means 1 square, a is 1 plus c, and this implies that c is equal to this 1 by 2 log of 2 I am taking in the left hand side minus 1 by 2 log 2. So this is value of c. The value of c you can put here. Therefore equation 1 implies phi equals 1 by 2 log of a square plus 1, putting value of c which is minus 1 by 2 log 2. Then phi equals 1 by 2 is common, and after taking 1 by 2 common, log of a square plus 1 minus log 2 means log a minus log b, or log of x minus log of y is log of x by y, law of logarithm. So in this way value of phi we found. The value of phi we found means we solved this integral. Now the next problem, show that value of this integral is tan inverse alpha by 2. Let us denote it by I or phi. 0 to infinity e power minus 2x sine of alpha x dx. This is divided by x. Now take derivative of phi with respect to alpha. Write down derivative inside of integral, it will become partial derivative. Direct step I am writing. Take derivative very carefully. Derivative with respect to alpha I am going to take, keeping x constant. Here x is constant, e to the power minus 2x is constant. This is multiplicative constant. Alpha is variable for derivative. Derivative of sine is cos of alpha x with respect to alpha, but derivative of alpha x is x now with respect to alpha, or you can directly write the coefficient of x, coefficient of alpha here. Now x gets cancelled. The e to the power minus 2x cos alpha x for 0 to infinity. Okay, this formula we can apply because this formula previously we used. E to the power minus ax cos of bx is a divided by a square plus b square. Here a is 2 and b is alpha. So it should be minus here, no? Minus of ax we want. 2 divided by 2 square plus alpha square. This is the differential equation we found. Now we are going to solve this differential equation in order to find out value of phi. Separate variables, d phi equals 2 times 2 square plus alpha square. Take integration of both the sides. Here on the right hand side alpha is variable of integration. Now integral of 1 with respect to phi is phi. Just one more step I am writing. D alpha by alpha square plus 2 square I am writing. Now integral of 1 with respect to phi is phi 2 times integral of, here I am writing integration of 1 by x square plus a square. Many times here you use in 12th standard. It is 1 by a tan inverse x by a with respect to x, okay, plus integration constant c. So this integration formula I am going to use. Here alpha is variable now. So what is the integration of this? 1 by a tan inverse x by a or alpha by 2 plus integration constant c I am putting. This 2 gets cancelled. Therefore phi equals tan inverse alpha by 2 plus c. The value of phi we found. Now it remains to find out value of c. And how to get value of c? the value of C I'll get from the definition. What is the definition of the function? How the function is defined? Here phi equals 0 to infinity e power minus 2x sine of alpha x, this divided by x with respect to x. Now, for which value of alpha parameter the phi becomes 0? The sine 0 is 0 is for alpha equal to 0. Phi is 0. Because if you put alpha equal to 0, sine 0 is 0. 0 multiplied by this will be 0. 0 by x will be 0 and integration of 0 will be 0 again. Therefore, phi is 0 for alpha equal to 0. So, this condition I am going to use, you may call this as equation 1. Let's put phi equal to 0. Phi means phi of alpha, you know. Phi is 0 and alpha is 0. The phi equals phi is 0. Equation 1 implies I am putting these two values here. Tan inverse of 0 plus C, and tan inverse of 0 is 0, therefore C is 0, because tan inverse of 0 is a multi-valued function, or you may take at least one value for in order to find out the value of C. Tan inverse 0 is 0, one of the values, the C equal to 0. This C equal to 0 again I am putting here. So therefore equation 1 implies phi equals tan inverse of alpha by 2, and phi is the given integral. Phi is equal to this integral, and phi equals tan inverse alpha by 2 we have shown. Now this one, now using differentiation under integrals I will find d phi by dA, where phi equals 0 to infinity to the power minus ax sin x by x dx. Then evaluate this integral by assuming 0 to infinity sin x by x equal to pi by 2. Okay, this condition is given to you in order to find out value of C. Now, this is our equation 1. Differentiate 1 with respect to parameter A. Differentiate with respect to A. Here A is a parameter. d phi by dA is integral of, directly writing inside of integral del A of e power minus ax sin x, this divided by x with respect to x. Take derivative with respect to x with respect to A very carefully, and that is a partial derivative keeping x constant. Here sin x is constant, x is constant in the denominator. Derivative of e to the power minus a multiplied by constant is what? E to the power minus ax, same thing, and a is the variable of derivative. The coefficient of a minus x we have to write while taking derivative. So dx is as it is. Now, if try to solve it for one more step, here x gets cancelled, minus you can write outside 0 to infinity e to the power minus ax, and sine of x is as it is. Sine x I am writing sine 1x. Now, the e to the power minus ax, this formula I am using, it is for 0 to infinity only. Sine bx, previously we used cos formula, now sine formula. It is b by a square plus b square. Now, this is b. b means 1 here. This square plus 1 square. So this is differential equation from phi. X we have removed. I am calling this as equation 2. Now, separate variables d phi 1 by a square plus 1 dA. We have separated a and phi. Take integration in the same step. Integral of 1 with respect to phi is phi. Integral of this is 1 by a square plus 1 square is 1 by 1. Tan inverse of a by 1 means tan inverse of a plus integration constant c I am putting. This is the value of phi with integration constant c. Now we have to find out the value of c. in order to get value of c, try to use definition of the function. What is definition of how the function is defined? 0 to infinity e power minus ax sin x by x. But here, for which value of a phi is 0? For which finite value of a, you can say phi is 0, because a should be finite here. Okay, this a is finite. For which value of a phi is 0? So we don't have value of a for which phi is 0. But here in this case, this condition is given to you. If you compare these two, this is phi, this is given. If you compare these two, here a is equal to 0. If you put a equal to 0, this I'll get. So what I am going to do, put a equal to 0 here. And if you put a equal to 0, what will you get? Value of phi for a equal to 0 is 0 to infinity. If you put a equal to 0, e raised to power 0 is 1. This will remain only. Sin x by x will remain. And integral of sin x by x for 0 to infinity is pi by 2, which is given to you in the problem. Means the value of phi is pi by 2 when a equal to 0 is pi by 2. For a equal to 0, value of phi is pi by 2. Now, use this condition in order to get the value of c. Put phi is equal to pi by 2 and a equals 0. A is the parameter. If you substitute here, then equation 3 becomes, this is pi by 2, because phi is pi by 2 for a equal to 0, minus tan inverse of 0 plus c, and tan inverse of 0 is 0, one of the values, c equals pi by 2. The value of c is pi by 2. So put value of c here in equation 3. Therefore, equation 3 implies phi equals minus tan inverse a, and the value of c I am putting, which is pi by 2. So this is the value of phi a or phi alpha, you can say. This integral we have solved like this, and value of this integral is minus tan inverse a by plus pi by 2. The next problem, evaluate phi of a equal to this. Here a and b, two unknowns are there, or you can say the parameter. But in this case, a is the parameter we are going to take, and the function indicates that phi of a means this is the function of a. And what about b then? B will be arbitrary constant. B we have to treat as a free constant, arbitrary constant. So only a is the parameter. Then take derivative of this with respect to a. d phi by dA is 0 to 1 del a of x power a minus x power b. You don't forget that the b is constant. Now take derivative of this with respect to a, keeping b constant and x constant, because this is the partial derivative. 0 to 1 derivative of x to the power a. A is very well of derivative. Derivative of constant raised to power variable is same thing, multiplied by log x minus, in the denominator log x is already there, because for derivative log x is constant, as it is I kept here. Now b is constant, x is constant, derivative of constant is 0 with respect to a. Now here log x gets cancelled, integration of x to the power a with respect to x. X is variable now for integration. X to the power constant, you can say, is x to the power n plus 1 or a plus 1 by a plus 1. So lower limit is 0, upper limit is 1. If you put x equal to 1 by a plus 1 you will get. If you put x equal to 0, then 0 by a plus 1 you will get. Therefore, d phi by dA is equal to 1 by a plus 1. This is the differential equation. Okay. This may be asked as an answer. Now, separate variables. I am separating variables d phi. Okay, this differential equation we have already solved. Take integration. Then integral of 1 with respect to phi is phi. Integral of this with right hand side with respect to a is log of a plus 1 plus integration constant c. Then this is our equation 2. Find the value of c now. How do you get value of c? From phi I will get value of c. Phi is 0 to 1 x power a minus x power b by log x. If you look at this function, integrable function, for which value of a, parameter is a, b is constant. For which value of a, phi is 0. For a equal to b, if you put a equal to b, x power b minus x power b will be 0. Phi is 0. If you put x a equal to b, then phi is 0. Means for a equal to b, phi is 0. So I am putting here a equal to b. What will I get? Phi is 0 for a equal to b. Put a equal to b and phi is 0. Therefore, c equals minus log b plus 1. This will be shifted on the other side. And put value of c here. If you substitute value of c, then phi will be what? Log a plus 1. And value of c is minus log b plus 1. And log of a plus 1 minus log b plus 1 is log of first argument by second argument. A plus 1 by b plus 1. So in this way, we have solved this integral. This is the value of this integral now. Log of a plus 1 by b plus 1. Now very quickly, again the same problem. We have two unknowns a and b. But here b is the parameter. Here a was the parameter. Here b is the parameter. And a should be treated as constant. This is our equation 1. Okay, in short I am going to write it. d phi by db. B is parameter now. Integral 0 to infinity. Differentiation under integral sign rule I am using. This is as it is. Divided by my x is there. Then take derivative with respect to b, keeping x constant, keeping a constant. The integral of partial derivative with respect to b I am taking. A is constant and x is constant for b. Derivative of first term is 0. Derivative of e to the power minus bx is as it is because b is variable of derivative, you can say in this way. And coefficient of b is minus x variable. This divided by x is there. Now 0 to infinity. X gets cancelled, minus minus become plus in this way. Now integration of e to the power minus bx is e to the power minus bx. This divided by minus b. We are taking integration with respect to x now. d phi by db. And here lower limit is 0, upper limit is infinity. You put x equal to infinity, e to the power minus infinity is 0. E to the power 0 is 1. Directly writing. Minus 1 by b is there. Put x equal to infinity, e to the power minus infinity is 0. E to the power 0 is 1. means it is minus minus become plus 1 by b. Now d phi by db is 1 by b. Separate variables, d phi is db by b. P and phi I have separated, and take integration now. Integral of 1 is phi, integral of this is log b, plus c integration constant I am putting. Okay, this is our equation 2, and rest of the part I am going to write here. In order to get the value of c, this thing I have to use, but for which value of b? Phi is 0. If you put b equal to a, then e to the power minus x minus e to the power minus x will be 0. Means for directly writing, for b equal to a, phi is 0. So this I am going to use here. Phi is 0 for b equal to a, means b equal to a and phi equal to 0 I am putting. So c equals minus log a. Putting value of c here in equation 2. Equation 2 implies phi equals log of b, putting value of c which is minus log of a, and log b minus log a is log of b by a. This is value of phi, and phi is this integral. In this way we have solved this problem. We stop here. Thank you very much.